Hello, I am Seema and welcome to part 44 of the chapter Organic Chemistry, Some Basic Principles and Techniques. In part 43, we were discussing Kjeldahl's method. Moving on with our discussion of Kjeldahl's method, where I explained the method to you, I told you how the mathematical calculations are done. We now move on with the same topic and I tell you what are the exceptions. What are the conditions under which nitrogen is present in the organic compound and yet you cannot use Kjeldahl's method for its estimation. Whenever nitrogen is present in a ring, either in the form of a nitro group or as an azo group, you cannot use Kjeldahl's method. Look at the structures of these, The nitro group has a structure like R, N, and a single bond and a double bond, O, a single bond and a double bond, O. That is, there is resonance here. So this is positively charged and this is negatively charged. So where R, you would say, you could call it instead, since it is aryl, it's in a ring, you would call it an aryl group here. So when you have the nitro group in the aryl attached in the ring itself has resonance and the nitro group also has resonance. So whenever there is resonance involved, it imparts stability to the compound. And due to that stability, the additional stability due to resonance, it does not participate or it is not that reactive. The more stable a compound is, the less reactive it is. So whenever you have nitrogen in a situation where it can participate in resonance, it will not give the Kjeldahl's reactions. Therefore, you cannot use Kjeldahl's method whenever you have nitrogen either as a nitro group in the ring or as an azo group. What is an azo group? And diazonium, you would say. The azonium here. This is the azo group, N double bond N, where both the hydrogens have been replaced by an alkyl or an aryl group. So here also we see that nitrogen, if it is with the aryl group here, it would be involved in the resonance. It would be more stable and therefore it would not be available to participate and form the ammonium sulfate. And the example that has been given is pyridine. Pyridine is where you have nitrogen in the ring, like in the benzene ring. So in pyridine also a kind of azo group, a substituted azo group you would say, it appears to be that. And here also nitrogen participates in resonance and therefore this nitrogen cannot be removed to form the ammonium sulfate salt. That is why the exceptions in this case, this method is not applicable to compounds containing nitrogen in the nitro and azo groups present in the ring. For example, in pyridine, as the nitrogen of these compounds does not change to ammonium sulfate. Under these conditions, due to resonance, they acquire stability and are not available for reaction with sulfuric acid. So this was the exception of Kjeldahl's method. Now this is a solved example of your textbook, that is question 12.22. The question reads that during estimation of nitrogen present in an organic compound by Kjeldahl's method, the ammonia evolved from 0.5 grams of the compound in Kjeldahl's estimation of nitrogen neutralized 10 milliliters of 1 molar H2SO4. Find out the percentage of nitrogen in the compound. Do you remember what we did in the previous video? I told you how do we calculate. We find out the amount of nitrogen that was present in the ammonia which reacted with H2SO4. So if we know the amount of H2SO4 used from the ammonium sulfate that was produced, once we know the amount of H2SO4 used, by stoichiometry of the equation, we can know the amount of ammonia that was used. So what are we going to do? What is the reaction here of interest to us? Ammonia twice NH3 reacts with H2SO4 and results in the formation of ammonium NH4 whole twice SO4 sulfate. Right? For every 1 mole of sulfuric acid, you need 2 moles of ammonia if they have the same molarity. So what does the question say? What is the mass of the compound? The original mass of the compound is 0.5 0.5 grams. This is the amount of compound that we have, 0.5 grams. Out of this, what amount was nitrogen? And then we'll find out the mass percentage by this amount of nitrogen is present in this mass. So how much would be present in 100 in these many grams? So how much would be present in 100 grams? So 0.5 grams is the original mass of the compound in Kjeldahl's estimation of nitrogen. The nitrogen neutralized 10 milliliters of 1 molar H2SO4. 1 molar, so this should also be 1 molar. 1 molar H2SO4 was 10 ml. If it was 10 ml, how much of ammonia would have been used up? It would have been twice of this. So twice into 10 ml, which is equal to 20 ml. So 20 ml ammonia is the volume of the ammonia that was used. So we'll say 20 ml of ammonia was produced. Alright. Now we know that 1000 and what is the molarity? It was 1 molar. So 20 ml of ammonia, 1 molar ammonia would be produced. So 1000 ml of ammonia, 1 molar ammonia has nitrogen equal to 14 grams. We know this, that in 1000 ml of ammonia, 1 molar ammonia, the mass of nitrogen will be 14 grams because the mass of 1000 ml of ammonia, 1 molar would be 17 grams. 3 grams is nitrogen, so you're left hydrogen, so the mass of nitrogen is 14 grams. So that is 14 grams. So for 1 ml, how much would it be? 14 upon 20. 14 upon 1000. And for 20, how much would it be? 14 upon 1000. And for 20 ml of ammonia, the mass of nitrogen would be equal to 14 upon 1000 into 20 grams. Now this is the mass of nitrogen. And you need to find out the mass percentage. You have to find out the percentage of nitrogen. So how do you find out the percentage of? This is the amount of nitrogen that was produced from how much of the compound? From 0.5 grams of the compound. So we'll say 0.5 grams of the compound has nitrogen equal to 14 upon 1000 into 20 grams. So 1 gram will have into divided by 0.5. 1 gram will have divided by 0.5 and 100 grams will have how much? Into 100. That will give you the percentage. That would be the percentage of nitrogen. Therefore, when you calculate this, the percentage of nitrogen would come out to be equal to 56%. 56% would be the percentage of nitrogen in the compound. Right? So now there is one textbook question also that I would like to solve to make the calculations the way you calculate and to explain Kjeldahl's method better. So I'll just wipe off the board and write down that problem and I'll solve that also, and I'm sure after understanding that you would be good to go for Kjeldahl's method at least. So give me a minute. This is now question 12.33 from your textbook exercise, and this is a wonderful question because it will involve all kinds of calculations that I have explained in Kjeldahl's method. And with this problem, I'm sure you're going to be confident in the method after having solved this problem. What is the question? A sample of 0.5 grams of an organic compound was treated according to Kjeldahl's method. So I'm going to, really write down what all we are being given. A sample of 0.5 grams, it means the mass of the compound is 0.5 grams, okay? A sample of 0.5 grams of an organic compound was treated according to Kjeldahl's method. The ammonia evolved was absorbed by 50 milliliters, 50 ml. So the total volume is 50 ml. Okay, it was absorbed by 50 ml, and what is the molarity? M is 0.5 molar. The solution is 0.5 molar. So 50 ml of 0.5 molar H2SO4. The molarity of H2SO4 is 0.5. The residual acid is required 60 milliliters of, now the volume of NaOH can be written as V1. The volume of NaOH is 60 ml, right? So the residual acid required 60 milliliters of 0.5 m. So the molarity of 0.5 molar NaOH also has the same molarity. 0.5, 0.5, okay? So 0.5 moles of molarity solution of NaOH for neutralization. You have to find out the percentage composition of nitrogen in the compound. Now, we know there are two reactions that are taking place here, which are going to, what is our aim? Our aim is to find out the mass of ammonia produced. And in order to find out the mass of ammonia produced, we have to first find out the exact volume of the ammonia. To do that, we will start from the end. What are the reactions that are taking place here? The last reaction here is between sodium hydroxide and sulfuric acid, where the neutralization of the 60 ml is taking place. So we'll say twice NaOH plus H2SO4. The neutralization takes place. NH4, Na2SO4, sodium sulfate, plus H2, Na2SO4 plus twice H2. Okay, this is the neutralization reaction that is taking place. Sodium hydroxide and sulfuric acid. And we have been told the volume of sodium hydroxide, yes, 60 ml. 60 milliliters is the volume of sodium hydroxide that's given to us. Then, what is the other reaction that is taking place? Ammonia, twice ammonia, NH3, will combine with H2SO4 to result in the formation of ammonium NH4 whole twice SO4 sulfate. So for 1 mole of sulfuric acid, there should be 2 moles of ammonia. This is what we did in the previous problem also. So these ratios, the stoichiometries of these two reactions are really important because they are going to lead us to find out the volume of ammonia produced. And once we know the volume, we can calculate the mass. Once we know the mass, we can calculate the mass percentage. So what all is given to us? The original mass of the compound is 0.5 grams. We know that 60 ml of NaOH is present. Now NaOH is not our focus. We know the total volume is 50 milliliters, out of which some reacted with ammonia to produce ammonium sulfate. The remaining reacted with 60 milliliters of sodium hydroxide. The remaining H2SO4 reacted with 60 milliliters of sodium hydroxide to get neutralized. So from this we can calculate what would be since the molarity of both NaOH and H2SO4 is the same. So if this was 1 molar, then you would need 1 mole of this and 2 moles of that if they have the same molarity. And since they have the same molarity, if this is 60 ml, this is actually twice of H2SO4. 1 mole, 2 mole, you see this? So what would be the volume of H2SO4? It would be half of 60. So we'll say volume of H2SO4 will be equal to half of 60, which is equal to 30 ml. We have now come to know that 30 ml of the H2SO4 was not used to react with ammonia. What was the total amount of H2SO4 that we took? The total was 50 milliliters. So we'll say, therefore, volume of H2SO4 that reacted with ammonia obviously was the total volume minus, when we did the formula, I called this V1. So the volume of H2SO4 here would be, if this is V1, then this would be V1 by 2. You remember? So it would be equal to V minus V1 by 2, which is equal to 650 minus 60 by 2, which was 30, which is 50 minus 30, which is equal to 20 ml. So we come to know that 20 milliliters of sulfuric acid reacted with ammonia. From this now we come to the second reaction, that if 20 ml of H2SO4 reacted with ammonia in a balanced equation, if we had 1 molar solutions, whatever the molarity is, if we had 1 molar solutions, 1 mole of sulfuric acid would react with 2 moles of ammonia. If we have 20 ml of 1 molar solution, then what would be the volume of ammonia for the same strength? It would be twice of it. So we have got 20 ml here. So 20 ml H2SO4 will react with ammonia, which will be equal to 20 into 2, which is equal to 40 ml. Am I clear? It would need 40 milliliters, it would react with 40 milliliters of ammonia. It means that 40 milliliters of ammonia of 0.5 molarity was produced by the compound, right? So now we need to find out the mass of 40 milliliters of that ammonia. We know that 1000 ml of ammonia, 1 molar ammonia, weighs 17 grams, out of which nitrogen is equal to 14 grams. Okay? So 1000 milliliters of 1 molar ammonia, it weighs 17 grams, out of which nitrogen is 14 grams. So 1 ml, if it is 1 molar, and if it is 0.5 molar, you will multiply it by whatever the molarity is. 1 molar is this, so whatever the molarity is, you will multiply it by that, right? You will multiply it by that molarity. So of 0.5 molarity would be this. So 1 ml, I'm using unitary method here, of 0.5 molar ammonia has nitrogen equal to 14 into, I'll remove the unit now because I know when I find out the percentage, and in any case I'll not have the units. So 14 into 0.5 upon 1000, right? But what is the volume that I have? I have 40 milliliters. Therefore 40 milliliters of 0.5 m ammonia will have nitrogen, which will be equal to 14 into 0.5 upon 1000 into 40. This will be the mass of nitrogen. Mass of nitrogen produced by how much of the compound? Mass of nitrogen produced by, what was the mass of the compound? Original mass of the compound, 0.5 grams of the compound. So we'll say that 0.5 grams of the compound has nitrogen equal to 14 into 0.5 into 40 upon 1000 grams. So 1 gram of the compound will have, divide by 0.5, and 100 grams will have into 100. Right, so the 0.5 will go here, 100 will go here, and when you 14 into 4 would be equal to 56%. Out of 100 gram, you'll get 56%. Right? So this was, this is 56%. So this was the mass percentage of nitrogen. And if you remember, let us say that you do not go into the entire, it is best to solve the problem like this, understanding every step, what happened, what did not. In other, it would have been easier if I would have just allotted these V1 by 2, and I had used the equation that was given in the textbook, that is, percentage of nitrogen can be calculated as 14 into molarity into twice V minus V1 by 2 upon 1000 into 100 upon the original mass of the compound. You could have used this equation and given the proper values to everything, and then if you would have substituted the values in this equation, you would have come to the same answer. but that would make it very, it would be just mugging up and trying to solve the problem, not understanding the actual method. So I would not advise you to do that. I would want you to understand the entire process so that you know what you're doing. So with this, we come to the end of Kjeldahl's method. If you found this video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.